Hello, welcome to the second part of our second chapter, chapter 2. And here, as you can see, we're going to look into computers. So, we're going to understand in a rough ways how a computer works. What are the components? What are the parts involved in a computer communication? So, we're going to discuss, basically, we're going to see um, the four communication parts that are involved, which is the input, the output, processing or processing unit, and the storage. So that's going to be our focus here. Okay, so our learning objectives describe the four main functions of a computer system and how they interact with data and information. Define bits and bytes very briefly, and describe how they are measured, used, and processed. List common types of computers and discuss their main features. Identify the main types of keyboards and touchscreens. Describe the main types of mice and pointing devices. Explain how images, sounds, and sensor data are input into computer devices. So basically, we're going to talk about the parts that compose a computer. Again, as I previously mentioned, it's going to be very rough, very shallow. We're not going to go too deep into it. The idea is just to see the devices, the peripherals, the parts that we have available nowadays. Then we're going to go to describe options for outputting images and audio from computing devices, describe various types of printers, and explain when you would use them, describe the functions of motherboard and RAM, explain the main function of the CPU, describe the various means of storing data and information with computing devices. And lastly, we are going to describe common types of ports used today, describe how to manage power consumption on computing devices, and very briefly just mention or just defining ergonomics and discuss the ideal physical setup for using computing devices, which probably you know, but we'll just go very quickly through it. So first of all, we have to understand our computer. And computers are data processing devices. To process data, there are some basic structure, basic components that are involved. So a computer performs four major functions. First, you have the input. So you have the information or the data. There is a difference between data and information, but that's not important. That's not important at the moment. But basically, the computer needs to receive an input. It needs to receive data where it can work on or work with. So that's the input. That's where the information comes from. So the input gathers data, allows entering data. Then it must process that information or that data. So it manipulates, calculates, or organizes data. This is where or when data can become information. So the difference between data and information is that information is the data that actually has some value. So when you manipulate or when you calculate that data, it can become information. Once that information or that data has been processed, we're going to have the output. So information comes in or data comes in, processing happens, so the computer does something with that information, and then it shows that information, or it, for example, prints the resulting data. The way it does it is through the output or output device. And then you also have storage. That's where computer saves data and information. So basically, if we try to associate with a real world situation, let's say that you just opened your Word document processor tool. So you're using the keyboard to enter data. So you're typing letters, symbols, numbers, whatever. The keyboard is the input device to the computer. Um, that input device is connected to your computer. So the keyboard is connected to your computer and it's working as the input device. The computer receives that data from the input device. It receives that uh, series that series of characters. And what is it going to do with that information? Well, that depends on the software. So in this case, if you're using the Word document processor, basically at first, what it's going to do is simply show to you what it just received. So it's just forwarding that information. What you type on your keyboard, the computer is going to receive and just forward that information to your display. The difference is it's not just displaying a character, it's the character or the characters are being treated because it's going to be displayed in a specific format, a specific font, in a specific size, and you have a specific color. So there are different ways of displaying that information. Now, the computer, which represents the processing unit, is responsible for treating that data, in this case the characters, and translating that character to a specific format. The format is simply displayed on your display on your monitor, but it's not the monitor, which is in this case is the output device. But it's not the output device that is formatting those characters. It's the computer itself. It's the processing unit or the processing part or the processing components that were responsible to format those characters. Now, in this situation, there is no storage. In this scenario that I just pictured, there is no storage involved. But then you can decide to save that file for later. Let's say that it's an important document, or you're going to have to add it later on. So you want to make sure that you have that information available. So you're going to save that file. That file is going to be saved in a storage device. Well, this is very, very basic. So the idea is to see different possibilities of input, output, processing, and storage components or devices, right? So just to remember, in case you don't remember, first of all, we have to have in mind that we have to understand the difference between bit and byte. Bit is just the presence of signal or the absence of signal. So 0, absence, 1, presence. You can have, since it's a bit, you have two possibilities. It's a binary digit, so 0 or 1, and an array or a vector of 8 bits compose a byte. And this is actually why you have the number of symbols, numbers, and characters that you do have. If you look at the number of possibilities that you have in your keyboard, it's going to be 256. That's because the 8 bits will give you 256 possibilities. So each character or number or symbol that you have in your keyboard is a combination of an array, a vector of 8 bits. And you also have more units. you, and you can even have those for bits or bytes. So you can have kilobits or kilobytes. Same thing for mega, gig, tera, and peta. So it represents, in the sequence here, we have 1,000 kilo, that means 1,000, so 1,000 bytes, a million bytes, billion bytes, and so forth, so on. Now, if we analyze well, in theory, if we analyze the power um, of computation, or how powerful a device is, this is how we could determine the most powerful family of computers. So cell phones, they would be the simplest ones, or the ones that are not that powerful when it comes to computation. Then you have tablets. Then you evolve to laptops and their variants, which is a bunch. And then you have what can be called stationary computers or desktops, right? Now, nowadays, this is not so true, because there are some, for example, there are laptops that are very, very powerful. They can even be more powerful than stationary computers. But in theory, this is how it goes, right? So these smaller devices tend to be less powerful in regards to computation, because they are smaller, and if they're smaller, you cannot have too many integrated circuits within those, because if you have too many, you're going to have power consumption, you're going to have heat, and these are the two main issues when it comes to power in computation. So it's uh, power and battery consumption and heat. Obviously, you want your phone, your smartphone, to be small. If it's small and you put too much computational power in there, it's going to heat up and the battery is not going to last. It's different as we progress here. Now, some examples of keyboards that we have are known by you are keyboard with the traditional, I'm sorry, not examples of keyboards, but examples of input devices that we have nowadays are keyboard, as you know, touch screen, virtual keyboard, and stylus. For those that don't know, stylus is just a commercial name given to those pens that you can use to replace your finger, for example. So instead of using your finger in the touchscreen device, you can use that pen. It's called stylus. Some other types of input devices, we have mouse, we have trackpad or touchpad, whatever you want to call it, and game controllers. And game controllers have so many variants, right? Now, those are the traditional input devices when it comes to using computers. But we also have some very different types of input devices, right? Devices that are going to receive, or digital computers that are going to receive data as an input. So, for example, popular for images, we have the digital cameras, we have camera recorders, mobile device cameras, flatbed scanners, webcams. When it comes to sound, we have microphone, and obviously you can have microphone with voice recognition software, but that's not mandatory. Just using a microphone will give you will give you an input device, obviously. We also have sensors, and sometimes it may look kind of abstract when you see this word sensor. But a good way of representing, of seeing a sensor would be uh, taking a look at early warning systems. such as hurricane early warning systems. So there are systems that will detect when a hurricane is coming, when well, at least they try to create I'm sorry, not hurricane, but earthquake early warning systems, although it's a lot more difficult to censor um, earthquakes because they come so fast, but there are sensors for that. Basically, this type of sensor, uh, it would try to measure the vibration of the soil, right? So if it happens above a specific threshold, then it may seem that there is an earthquake coming. Same thing to other natural disasters. By the way, there are cyber early warning systems or attempts of creating cyber early warning systems, systems that are capable of analyzing behavior and say, hey, according to this behavior, a cyber attack may be coming. We also have the output devices. So the devices where the output will be displayed. So some very traditional ones, for example, monitors, printers, speakers, earbuds, and headphones, right? So you can send data out of the computer in these different forms, for example, but not specific to these forms. These are just some of them: text, picture, sound, video. Now, this output this output device can be varied in so many different ways. So, for example, we have different types of display screens. Nowadays, we have LCD, although I think that LCD is not that common anymore, but you can still see it. So, LCD, LED, OLED, and basically the way that they work is based on pixels, aspect ratio, and resolution. So when you are about to purchase a display screen, these are the 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 resources or the definitions that are going to look into, right? So, well, you do have a definition, the definition of a monitor, for example, based on pixels. Although this is not that much used nowadays because the number of pixels are associated with the resolution. So usually you're gonna see the definition of resolution and also the aspect ratio, right? So you're gonna see, for example, if you're gonna purchase a projector, a digital projector, you're gonna look at the resolution. You're also gonna look at luminance, which is the basically it's the brightness capacity of that projector, but mostly resolution, because the resolution is what will tell you how good the resolution, that image, the image to be displayed, is going to be. The aspect ratio basically will tell you the ratio of your horizontal and vertical image will be displayed. So, for example, back in the day, a television would have a aspect ratio where the horizontal aspect was very similar to the vertical aspect, whereas in monitors or display screens, such as the ones that we have in laptops and desktop computers, you'd have a much larger horizontal definition than the vertical definition. And then this same type of aspect ratio became popular to televisions as well. So most TVs nowadays also have an aspect ratio similar to monitors, computer monitors. Now, when it comes to sound, we also have the speakers. So that's where the uh, the sound will exit. Some examples are surround sound speakers and wireless speaker systems. We have so many different types and so many different brands, so many different specifications nowadays. Um, but it's very common to see those home theaters being or sound bars in stores such as Best Buy, right? Because the sound is so high quality, and at the same time, you have that feeling that the sound is not coming from just one single spot. The sound is actually moving, so you can hear, let's say, an explosion coming from one side and the actors speaking their voice coming from another side or from the center or whatever. So nowadays these speakers, they are so high quality that they try to give you the experience of being inside that scene. So the sound will come, the sound will exit, the sound will be output to you according to where uh, that action is happening within that specific scenario. Also, you have the headphones and earbuds. Earbuds are becoming much more popular nowadays because they are improving so much. Back in the day, they were so low quality. And also, we can't forget the output devices such as printers. So you have inkjet laser printers, which are they are more expensive, but they're a lot better. They're faster. They're more high quality. Some other types of output devices, of printers, output devices. We have cloud-ready printers, all-in-one printers. Those are the ones that you have the printer, the scanner, um, the copier, and fax at one single device. And so many different flavors, so many different solutions, right? What is becoming very, very popular nowadays is 3D printers, especially in the US. 3D printers actually became cheap, or at least they're getting cheaper. But I would say that probably you can get a 3D printer. Maybe, I'm not sure. I didn't search for it, but I would say that you can get a 3D printer nowadays for maybe $400, $500, maybe even less. But more importantly, we have the processing and memory devices. These are devices that they go on the motherboard, right? So first, we have to understand what a motherboard is. Basically, a motherboard is what the component that has the integrated circuits that will connect all the other components. So, for example, if we look at the components that are required to process information, to receive data, process the data, and output, send that data out. We have these components. We have the CPU, which is the central processing unit. This is the component that will measure the capacity of your computer. Now, it's important to know that it doesn't, just having a powerful CPU does not mean that you're going to have a powerful computer, but this is the device or the component that is used as basis to measure the power of your computer. So, because it is the central processing unit, all processing happens here. Now, but you do have other components, very important components. So you have the ROM, the RAM, and cache. These are the components that are used to store information, and not specifically, this is not the storage device. So the RAM is where information will be temporarily stored. Now, all these ones, they are auxiliary to the CPU. So the CPU, while it's processing, it must store information in a very fast way. So it cannot, the CPU cannot store the data that it's using in a storage device such as the hard drive, because the hard drive is very slow. So it would not help. Actually, it would be a burden having the CPU interacting with the hard drive. The CPU is very powerful, but the hard drive is very slow. So what would happen? Well, it would be the same thing as purchasing a Ferrari and driving it in, not in a highway, but staying enclosed to a block that you cannot go over 30 miles per hour. So because of that, you need a equally fast, or maybe not equally, but at least a much faster storage location. That's why we have the ROM, the RAM, and the cache. The difference between ROM and RAM is that the RAM is volatile. So whatever is stored there, it will only be there for a while. For example, if you reboot the machine, it's going to be lost. Now the ROM is different. Whatever is stored there is stored there for good. Actually, it's burned in that ROM. And you also have the slots for expansion cards. So that's where you're going to plug your sound card, your video card, your Ethernet or Wi-Fi interface, or any other type of expansion card that you need. Now, all these components will communicate by these paths called integrated circuits that are in the motherboard. So the motherboard is the piece of your computer that will connect all these components. So the CPU is the brains of the computer. So it controls all functions of the computer's components, processes all commands and instructions, and as you know, and as we mentioned, and it's measured in hertz. It's common to see nowadays gigahertz. So gigahertz means billions of tasks per second, because tasks per second, hertz is the measuring unit for tasks per seconds. If it's gig, it means billions. So the CPU is measured in hertz, as I mentioned. Now you also see, you've been seeing, I would say, in the past maybe 15 years, I would say you've been seeing, or 10 years, you've seen this shift of definition or specification, better said, for CPUs. So I would say that 20 years ago, when we were about to purchase a new CPU, all that we'd look at would be this: the number of tasks per second that device is capable of computing, treating. So there was a time where if I had a CPU with 1 gigahertz, and then if I had the chance, I would purchase another one of 2 gigahertz, and then if I had the chance, I would replace it for another one of 3 gigahertz. But then a problem arose, which was heat. So because these CPUs, they were becoming so powerful and they were capable of processing data so fast, so quickly, they started to heat up in a way that they could not be controlled anymore, in a way that you could not maintain a low temperature, and high temperature caused these units to crash. So then um, assemblers came up with the idea of separating this single core or this single channel, right? Where, let's say, you had two running programs, as you can see here, two running softwares, software 1 and software 2, they would go they would go through the same core, the single core, because the CPUs had only one core. And then they came up with the idea of creating more than one core within the same CPU. Now, there's there are some people that they talk about uh, dual core or quad core as if you had, for example, in a dual core processor, they mention as if you had two CPUs, which is not the case. You still have one single CPU, but that single CPU now has dual cores, two paths to treat, process data. Whereas you're going to have one software going through one channel, another software going through on another channel within the same CPU. Now, you maintain the same uh, capability that you had before, let's say 2 billion tasks being executed or being computed in 1 second. But now, in that same amount of time, that same second, those same number of tasks being treated by the same CPU simultaneously. Keep in mind, this is not the same as having two different CPUs. And then, so you have the input device, processing components, output devices, but you also need to store that information. For that, you have the storage devices. The most common one, the traditional HDD, the hard disk drives, primary storage device, non-volatile storage, internal drive, external drive. So all these are the same as using the solid state drive, SSD. So SSD can also be used as a primary storage device, internal drive, external hard drive, just the same. The difference is it's not as it's not as slow as the hard drive, although it's not as fast as the RAM either. But it's faster and it's safer. The chances of corrupting data in a SSD drive is a lot less than in a HDD drive. And then you have the other ones that are common, especially when you go to other digital devices such as cameras, smartphones, and many others. So we have the flash drive, we have the flash memory card, which is the case you can see here. And for the past probably 10 years, we've been using and hearing a lot about cloud storage, which is the capability of storing your data in the cloud. So you don't need any of those storage devices. You don't, well, it's not that you don't need, but you can store your data in a device that is not kept by you. It's not your responsibility to guarantee that device is kept safe. So you don't have the possession of that device because it's gonna of that storage device because it's your files are stored in the cloud. So files stored on the internet, uh, some amount is free, or you can purchase additional storage, which means that probably you have at least one cloud storage solution. So, for example, if we mention Dropbox, um, I believe that Dropbox, and it may have changed, but back in the day, Dropbox would give you 2 gigabytes of storage space, and you were able to increase that according to a bunch of stuff that you could do, but it comes to a point where you have to purchase more. Most of the cloud storage solutions follow this same pattern. You also have some peripherals to connect to your computer through computer ports. It's also common to see USB ports, which they have a transfer rate of up to 10 gigabits. Now here it's important to notice that the it's a lowercase b, which stands for bits, not bytes. It's gonna be bytes when you say capital B, such as, let's go back, and I believe that we have this somewhere, but it's gonna be so far. But yeah, so capital B stands for bytes, lowercase b stands for bits. Those that are Mac users are more familiar with this terminology here, Thunderbolt. So the Thunderbolt port is a faster port up to 40 gigabits per second. It's common for Mac users because that's the same port that you can use to uh, adapt, use the adapter to a HDMI port. So in case you have a MacBook, probably your MacBook doesn't have a HDMI port. It does have a Thunderbolt port, and you're going to need the adapter to connect to that port. And then we also have so there are many other different types of ports. We have ports to connect to what we mentioned here, um, like the flash memory cards, but we also have the Ethernet port. That's the port that you use to connect to the network, to get connectivity to the network using that blue cable, which is the Ethernet uh, data link. And it's becoming obsolete as well. This is becoming more common in for servers, for a for the basic infrastructure, but not for end users. End users keep the number of end users that are changing from Ethernet wired connectivity to wireless connectivity keeps growing. So we have more and more people adopting Wi-Fi and not using wired technology anymore. Now, it's also very important to keep in mind that the reason why smartphones and tablets they don't get too powerful, and that is because of the power management issue. As previously mentioned, well, I don't know about you, but I believe it's going to be the same. I don't want my smartphone to last, let's say, 2 hours, 3 hours a day. So I don't want to charge my phone every 2 hours. I want my phone, well, I wish my phone would last 2, 3 days without recharging, but that's not possible, at least not for my phone. So I have to charge it every day, but at least I charge it when I go to bed. When I wake up, I unplug it. That's not bad. It would be very bad if I had to charge it every 2 hours or let's say 3 times a day. So if we had very powerful CPUs within these devices, then that's what we'd have to do, right? So battery drain is a big issue because of the power supply. Sleep mode is also a resource that we have available in order to avoid battery drain, battery consumption, similar to hibernation. Now, just a guideline here that you have to keep in mind, you have to be aware of these ergonomics. Remember, when you work in IT, or not even if you work in IT, but when you're using IT resources, you have to remember that these ergonomics guidelines are very important to your well-being. So always remember that you have to position your monitor according to your height, and the same thing is is valid for your chair. So your chair must be adjusted to your height as well. Always proper type, uh, properly position while you type. I mean, not only your body, but also your arms and hands. And always use adequate lighting. This is very elementary, sometimes even obvious, but we have to remember, you guys, that this is very important for your own well-being, and we must aware of those guidelines. So our chapter 2 was on, or is actually, on looking at computers, understanding the parts. For some of you, maybe this was a very basic topic, but as we mentioned previously, we're gonna evolve with as the chapters go. So we started discussing, basically discussing social media and how to use the internet, what are the benefits, the pros and cons of using the internet. Now we're going to a more technical, we just went through a more technical subject, which is computer components, and we will evolve as the chapters progress. I hope you enjoyed this discussion. Thank you very much. And remember, do the assignments. Um, I will send out at least one announcement explaining the assignments. Thank you very much.